So here we are going to look at the jet transforms of some of the most commonly used sequences. Okay, so if you consider, like, I have already discussed this discrete time sequences in the first lecture itself, like in the basic introduction lectures. So what is this first one? That is impulse sequence, which is going to exist only at n equals to 0. Like, all those things you need to know, then only you can derive this jet transform formula using the fundamental formula of jet transform, that is x of z equals to sigma n equals to 0 to infinity x of n z to the power minus n. Okay, so if you perform that here for this impulse sequence, you will get it as 1. That means jet transform of impulse is nothing but 1. And what about the ROC? ROC will be all Z. Okay, that is the region of convergence. Then coming to the unit step sequence, that is U of n. So its Z transform will be Z by Z minus 1. And you can also write it as 1 by 1 minus Z inverse, and ROC will be Z greater than 1. Similarly, if you multiply n, that is time in discrete domain, and with step input, that is u of n, that is n into u of n, you will get z transform z inverse divided by 1 minus z inverse whole square. You can also write it as z by z minus 1 whole square. There is a property for this. Okay, with that property you can directly write this formula using z transform of u of n. Okay, right. And for this also ROC is z greater than 1. Okay, then for e power minus j omega n u of n, it will be z by z minus e power minus j omega. That means it is in the form of a power n into u of n. So for that, the z transform is z by z minus a, right? That means for a power n into u of n, it is z by z minus a. Here in place of a, what is there? E power minus j omega, that is there in place of a. So here in place of z by z minus a, you will get z by z minus e power minus j omega. That's it. Similarly, for e power j omega n, where a will be e power j omega, you will get z by z minus e power j omega. Okay, right. Then for sine and cosine sequences, it is very important to remember this sine and cosine, because in exams you can directly write the inverse of z transform, or you can write the z transform of sine and cosine also. So it is z, the denominator will be same for both of them, only numerator is going to vary. That is, for sine omega n, it will be z sine omega by z square minus 2z cos omega plus 1, and for cos omega n, the numerator will be z into z minus cos omega, but denominator is same like sine omega n, that is z square minus 2z cos omega plus 1. Okay, that's it. These are the most commonly used sequences, z transform and its ROC. So in the next lecture we will see the ROC properties, like how you are writing, how to easily remember them. Okay, thank you.